Hello!
Hello!
We are back with our crystallization experiment, right?
Yes.
Mm-hmm.
Yes, it's been a little more than a week instead of one day. It took some time for all the evaporation to take place, for all the water to dry off.
Mm-hmm.
Yes.
So, but anyway, we have the experiment under here. This is Stella's painting.
Yes.
So here we go. You want to show your painting?
Look. I did so good.
Mm. Very pretty. Beautiful.
So anyway, here is our experiment.
Mm-hmm.
Now let's open this. So, and have a look inside. Wait a second.
Have a look inside.
There's crystals.
Mm.
Yes. There is very deep.
But it's maybe not perfectly like on the box. What do you think?
It's still a crystal.
Yes, it's true.
Yes. It is.
But it didn't really make these radiating star-shaped things like on the back, on the back. What do you think?
Yeah.
I think it looks fantastic.
Yes.
Looks like a salt lake.
Yeah. To me it looks
Or
like
a
salt.
stone.
It's like a salt. There's a stone and there's a little bit of small crystals on the salt. Well, there's salt-like
rock?
crystals on the rock as well.
Yes.
You can see there is small crystals.
And the little bit blue from the ink we put in is in there as well.
Yes.
Yeah, it looks like, you know, I once been in Spain and there is evidence for the Mediterranean Sea having dried out. And there we have crystal beds, evaporites, like that.
Wow.
Yes. So, and I brought you a picture here.
Okay, let's have a look at the picture.
This is a salt lake in Bolivia, a salar.
Salar.
Yes, salar. And it looks like this. See? There's tiny little crystals all along the lake bed. And all the water has dried out.
Wow.
It's evaporated. Because it's very dry there. And here, look. This is how it looks in detail.
Wow.
Incredible.
Incredible. It looks like ice.
Yeah. It looks like ice, but it is not. But remember, we've been in salt plantations in the Canary Islands. And they look a bit like that.
It looks like a planet.
It is on the planet, but it is almost another planet. It looks a little bit, almost,
like
well,
on the
spooky.
North Pole, like.
Yeah, but it's not ice, it's salt. And this is what we see here, I think. Does it look a little similar?
Yes.
There's another place in California, which is called Mono Lakes. And let me see whether I can find it for you. And Mono Lakes is one of the lakes that provides the water for Los Angeles, one of the big cities. And it's now pretty dried out. And it looks a bit like this as well, I think. Let's see whether we get this. Yes, here. Here's some pictures of Mono Lake.
Okay.
So it's drying out. And you see some of the big crystal columns, the tufa columns as they're called, they're standing out.
Wow.
So
Okay.
there you see many pictures of it. Let me get you a good one.
That's cool.
Here, look at this.
Wow.
This is with a little bit of water left. The water is not completely gone, but you see how the crystal mountains, the little columns, they stand out, and at some point all the water will be gone and the lake
like
will have dried out, and then you see a situation very similar to what we see in there.
Dad, it looks like ice.
Yes, it does look like ice. And it's not ice,
No,
it's crystals. And one intriguing fact is that these crystals in these salt lakes, in the salars, they have an element called lithium. And lithium is very important to make batteries.
Yes.
Batteries for electric cars and other electrical devices. Lithium batteries, they will be very important for the future because we want to stop burning so much oil and fossil fuel and petrol. So lithium comes from salt lakes, and these are actually very important for us and for our future. So, did you learn enough about salt crystallization and salt lakes?
So the tiniest thing can be one of the most important things.
The tiny crystals of salt will become very important for us because the lithium is kept in the crystal when the water goes off, and then we can take it out like in a quarry. We take the crystals and we can get the lithium out, and that will, go easy, that will help us to make batteries. Don't destroy it yet. I want to show it to my students in class as well. Is that okay? And by the way, you remember Dimitri from one of the videos? He did an experiment as well, and here, have a look. That's Dimitri's experiment. And it does look a little similar. We didn't have any ink in there. It was all white crystals, but have a look.
Wow, that's so amazing.
Yes, and it's a very similar result. Surprisingly, so leave it there, then the camera can focus better.
Yes.
So you've put in a rock there as well.
There's a rock, it's a different rock. Can you just, Stella? Thank you. It's magnesium, it's an olivine-rich rock, magnesium and iron-rich minerals. And the previous sample was more of an alkali rock with a lot of sodium and potassium. So the rocks were slightly different, but it doesn't seem to make a huge difference. See the little kind of polygonal shapes of the crystals here at the very bottom?
Give it peace, Stella, for a moment.
I think we got one there. Yeah.
Wow.
Incredible.
Yes, indeed.
Beautiful.
And yes, beautiful.
Tiny miracle.
Yes.
So, and well, in order to make crystals like they do on the box, I think we have to do a few more experiments, but step by step. I think we have an interesting result here anyway. And
It's a
I
start.
think we also learned that crystals, they seem to concentrate on the substrate. They grow on surfaces, like on the rock, as well as on the floor of our little container. Rather than swimming in the liquid, they seem to actually crystallize from a surface. So, Stella, can you see them?
Yes.
Have a good old look.
Can I?
So, I think, guys, we should say goodbye to not keep our audience for too long, because I think we can explore this now in more detail. So, thank you very much for joining again. Bye-bye. And don't forget, lithium comes from salars and salt lakes come from dried out lakes. Bye-bye.